Howdy. This is a Mountainwater video. There are lots of mountain and a lot of water. I just stumbled across an article, some 2 days old. I haven't read it yet, but it sounded very, very interesting, so let's dive into it and read it. This is Science Magazine or whatever that is. It's just mind-boggling. More than 19,000 undersea volcanoes discovered. 19,000. New seamount maps could aid in studies of ecology, plate tectonics, and ocean mixing. Yeah. And if you think about the possibility that many of these volcanoes could possibly erupt just by spitting out water. Yeah. On the bottom of the ocean. It might be even warm, you know? The 76 meter tall Pow Pow seamount right in the South Pacific Ocean has been mapped by sonar. Many others haven't. Yeah, that's a huge mountain. Anyway, let's go into that. The US submarine fleet's biggest adversary lately hasn't been Red October. In 2005, the nuclear-powered USS San Francisco collided with an underwater volcano, or seamount, at top speed, killing a crew member and injuring most aboard. It happened again in 2021, when the USS Connecticut struck a seamount in the South China Sea, damaging its sonar array. Yeah, if there's something in the way of the, let's just say, enforcement forces, the army, they will make sure of it, that they understand it, so there's no, how to say, border or boundary for the amount of money which will get spent into that. It's a different thing than science, you know. But anyway, with only 1/4 of the seafloor mapped with sonar, it is impossible to know how many seamounts exist. But radar satellites that measure ocean height can also find them by looking for subtle signs of seawater mounting above hidden seamount, tugged by its gravity. A 2011 census using the method found more than 24,000. Yeah, whatever that means, I don't really get that sentence. But anyway, high-resolution radar data have now added more than 19,000 new ones. The vast majority, more than 27,000, remain uncharted by sonar. It's just mind-boggling, says David Sandwell, a marine geophysicist at the Scripps Institution of Oceanography who helped lead the work. For those who have seen Mountainwater videos, I have a playlist. You have probably heard me saying many times that I think the possibility that we have many more volcanoes on land than previously thought. In this case, this is about the same. They just found thousands of volcanoes more. And I'm pretty sure if people would understand that every hill or mountain where we have water flowing out is still an active part of the geophysical environment. Water is highly conductive. It is in the ground, on the ground, and in the air. We can see the clouds rolling by. And it's just about the amount of charge of our planet Earth in order to make the spheres of the waters expand or what is it? Decrease? No. Contract, probably. So, if they are able to find thousands of volcanoes on the seafloor, if people would wake up to the truth that cryptodomes, hence source domes, in other words, a mountain where is water pouring out, would be seen as volcanoes, and the possibility of the amount of water pouring out of that mountain can very well fluctuate. And it probably has been much more intense back in the days when the Romans roamed the earth, because they built so many bathing facilities all over Europe. Nowadays, if they find something, there's no water, but it's still a bathing facility, so we have to assume that back in the days there was water. And since history repeats itself, we might have to assume that the water will come back. Probably more than expected, or more than it's able to handle, like all those dams which are built in wherever valleys all over the world in the last, let's say, 100 years. They might not hold the amount of water which could all of a sudden pour out of the mountains. But anyway, I will put a link below to my Mountainwater paper. This would be maybe a thing which could help you to understand what I'm talking about. But it's work. You have to read it by yourself. And it takes some time to read it. Maybe it takes even some more time to think about the whole thing. But I just recommend you to read the paper. And actually I could show this Mountainwater, a new approach to mountain forming, volcanism, glaciers, and the role of water in an electric environment. The picture quality isn't that good, but something went down in the past. And this picture is from a region where I grew up, so I know the area very well. Textbooks and geoscientists may be wrong about how the Alps were formed. So this is now a layman's text. Since the scientists don't know, tell us that they don't know, we might just have to accept that someone outside of the scientific realm tries to explain some things. There are some pictures, not too many because my computer didn't manage. We have a dragon castle, the river Rhine, pile dwellings. There's a quite big amount of pile dwellings around the Alps region. Did you know that? Some 120 or something. I'm talking about the Romans, their bathing facilities, because at the same place where you just saw in the beginning the rock formation, it's here. It's the exact same place, same city. Where you find also fulgurites. And the city isn't too far from the Kaiserstuhl volcano, and it is connected by the river Rhine. There's a straight energy connection there. Geothermal map of Europe. Just look at Turkey, for example. Bursa is black, which means there is a lot of heat. There are also other pictures. The North Pole circuitry explained by Bruce Leyburn. Maybe you want to watch that video. Sea urchin spines, jewel antennas. energy circuitry of Earth. We are talking about micronova. I just go quickly through the pictures. Because as you can see, there's quite something through. It's not maybe 30 pages or something, it's not too big, but we have a solar flare, and we have the Eiffel volcano, we have the Alps here in the middle. And this thing is starting here, goes through that loop and makes a touchdown here on the other side. Maybe I have to start again. So this is this arc. And we just have to imagine the other stuff going around here. Yeah, I'm not a good drawer, obviously. We have fractality, repetitive patterns. Here on this side, it's basically the same thing as here in the middle. And they are all over the place. This is a picture I found on Google Earth. That's why it's very interesting to go over to Google Earth. I just was following an earthquake near Brenner Bad, and as I have been talking about many times, bath. It has a connection to geothermal activity, which I think is a very big and important part of volcanism in general. Mountain water, geothermal activity, the water. Victor Schauberger, the White Rivers. For those who have seen my mountain water pictures, you have seen this picture many times. The picture is from the presentation Healing is Voltage from Dr. Jerry Tennant. It is understandable that mineral water has healing properties since it is water which comes with a charge. Nature searches for equilibrium and most people aren't in equilibrium. Circuitry, the connection between water and the fire element. Earth's core is also in my paper, but I think could be at the center of Earth, some kind of plasmoid. Deepest quake ever recorded, like it could be done better this, but let's go with that. We had brick floods. I remember. I've been there some weeks after the incident. Here is the Portal Lake. Here, the lake and its surroundings have a crater caldera-like shape. Bortlesee from top, Google imagery. I think it's fed from below, that's why we have this circular pattern. It's spreading into all directions because there is water coming from below. It would be very cool to go around there and check it out with my own eyes. The Bortlesee. Here is the city with the floods, and we have geothermal plant and a thermal bath. And after all the links or references, it still continues. The Nika crystal caves in Mexico. Yeah, because I was writing about like there might be very huge crystal caves underneath our feet where like the mineral water in a way gets created and stuff. And obviously these kind of caves are existing. There is a human for size comparison. Giant geysers, there's no picture. Hydrogen emissions, there's no picture as well. But anyway, let's go back to the other article. Published this month in Earth and Space Science, the new Seamount catalog is a great step forward, says Larry Meyer, director of the University of New Hampshire's Center for Coastal and Ocean Mapping. Besides posing navigational hazards, the mountains harbor rare earth minerals that make them commercial targets for deep-sea miners. Yeah. Their size and distribution hold clues to plate tectonics and magmatism. They are crucial oases for marine life. Yeah, we wonder why. And they are pot stirrers that help control the large-scale ocean flows responsible for sequestering vast amounts of heat and carbon dioxide, says John Lowell, chief hydrographer of the National Geospatial Intelligence Agency, which runs the US military satellite mapping efforts. Yeah. Nothing goes as well together as military and science. How sad. The better we understand the shape of the seafloor, the better we can prepare for climate change. Yeah. Subsurface eruptions, stuff like that. There has been quakes in, or still there are going on the Strait of Gibraltar. Just imagine if there would be some underwater eruption, you couldn't use a ship anymore to go there. It would be closed. Suez Canal, there has been quakes as well. And there are probably many, many underwater seamounts in the Baltic Sea no one is talking about, except me. Just one, and the whole Baltic Sea is closed. You cannot enter or leave it anymore. Just saying. But anyway, after the USS San Francisco accident, Sandwell and his colleagues secured funding from the Navy and NGA to hunt for seamounts with satellites. They identified thousands, including 700, particularly shallow ones that posed hazards to submarines. It's just think, like if no one knows about these, they have been probably, they could have been growing for many, many years. Like if the volcano is deep enough under the sea, there is nothing visible on the surface. It's, I don't know, 1,500 meters or something. It might be wrong, but there is some depth. But if it's a very big explosion or eruption, I bet you will notice something on the surface. If the whole water flies away, you know? But now let's just continue worrying about submarines. But the team knew its first catalog was far from complete. Now armed with data from high-resolution radar satellites, including the European Space Agency Cryosat-2 and SARAL from the Indian and French space agencies, the team can detect seamounts just 1,100 meters tall, close to the lower limit of what defines a seamount. All right, so there might be thousands and thousands more. Seamounts often occur in chains formed as tectonic plates ride over stationary plumes of hot rock rising from the mantle. Let me show you just once quickly something from my paper. And it's this picture. Because if you have the ability to imagine what I try to explain, this would be this kind of connection. It goes here. And if we would imagine that this would be the mantle, this would be the atmosphere, you know. These would be the places with magma chambers. And if you imagine this would be this kind of a plasma ball, if you touch a finger there, it just connects. And it would be just on a much bigger scale, planetary scale, and probably much more complex. But let's go to the paper because this video is stretching already very much. As a result, the catalog will pay immediate dividends for studies of Earth's interior. Says Carmen Gaina, the geophysicist at the Queensland University of Technology. It has already identified new seamounts in the northeast Atlantic Ocean, where we had this strange quake 2 days ago or yesterday. It was already It has already identified new seamounts in the Northeast Atlantic Ocean that could help track the evolution of the mantle plume that feeds Iceland's volcanoes. Ah, no. The survey also spotted seamounts near a ridge in the Indian Ocean where fresh crust is made as tectonic plates spread apart. Yes, Earth is growing. There's no such thing as plate tectonics, it's just growing. That's the thing. So it might crack up on some other places as it grows. They suggest a surprising amount of volcanism in a region once thought to be magma starved. Kinda says. Yeah, this is getting very interesting. This video could be continued endlessly. To biologists, seamounts' steep slopes resemble crowded, boisterous skyscrapers from corals and other marine life. They are oases for biodiversity and biomass, says Amy Becko-Taylor, a deep-sea biologist at Florida State University. Whales use them as waypoints, but biologists debate the role of seamounts play in marine biodiversity. Are they home to genetically distinct species like remote islands? Or do they serve as a stepping stone for life to hopscotch through the oceans? By pushing up the density of seamounts, the new maps could strengthen the argument for the latter, Bucko-Taylor says. They will also boost efforts to protect biodiversity in international waters under a new marine protection treaty. We can protect the things if we can't protect the things if we don't know they are there. Yes, it's about like the volcanoes. But anyway, if no one knows that there are volcanoes everywhere, no one just cannot give any thought about the whole thing because everyone lives in nations, a state of not knowing. Another thing is if you get provided with some information, but you dismiss it, you are acting ignorantly towards emerging new knowledge, and you do it consciously. This is the opposite of nescience. It is idiotism. You are an idiot. If you're acting like this, the Greeks figured out this word. It's an idiot. And I don't know if it's a scientific term, but it's a fact. So, nescience and ignorance are two very different things. If you have no possibility to know about something, no one can blame you for being ignorant. But if you know about something and you just don't care, don't do it. Just don't. It needs an open mind. It needs the possibility to admit of being wrong. Only then you can open your mind even more. But anyway, says Chris Jessen, a marine biologist at the Zoological Society of London's Institute of Zoology. The maps will provide a particle payoff, Jessen adds. We won't waste our time as much. Some of his colleagues, he says, once traveled to the Indian Ocean to study a seamount that turned out to be a phantom created by an error in pre-sonar depth records. A bumpy ocean bottom, satellites have detected more than 43,000 seamounts, but only 16,000 have been charted in detail by sonar from ships and submarines. Charted, uncharted. Look at that. Whoa. Nowhere will the new maps be as important as in understanding the ocean's globe-grilling conveyor belt of currents. The currents ferry heat from the equator to the poles, where the water cools and gains density until it plunges downward, carrying heat and carbon dioxide into the abyss. But the flip side of this perpetual motion machine, deep ocean waters defying gravity and rising upward. Yes, they don't understand gravity. Has long been a mystery. The upwelling was once thought to have happened even across evenly across the ocean, driven by turbulent waves at boundaries between deep ocean layers of different densities. Now, researchers believe it is concentrated at seamounts and ridges. There's a slew of interesting things that happen when you have topography, says Brian Erbick, a physical oceanographer at the University of Michigan, Ann Arbor. When ocean currents curl around seamounts, they create turbulent wake vortices that can provide the energy to push cold water up, says Jonathan Gula, a physical oceanographer at the University of Western Brittany. In an unpublished research, Gula and co-authors have found that these wake vortices make seamounts the leading contributor to upward ocean mixing and central player in climate. Nah, maybe not. Since the team relied on the old Scripps catalog, not the new one, the effect of the seamount is probably even larger. Yeah, just think of it. If there would be a huge amount of water pouring out of those underwater cryptodomes, some warmer, some cooler, you know, wherever you go on Earth, if you go on satellite like Google Earth and you just watch and start to zoom in, then you find a village and you go there closer, you will find water and you will find a mountain or a hill nearby where there's water pouring out. You know, sometimes there's a little church there and these kind of things. Just imagine the whole thing going on the seafloor. There's water pouring out all over the place. This is just what I think. The Seamount catalog is sure to expand further with Seabed 2030. Yeah, let's see. An international project to accelerate higher resolution sonar mapping that Mayor helping lead. But space service will improve too. Yeah, no, yesterday it didn't. Surface water and ocean topography satellite, launched in December 2022, can measure the height of a water surface to within a couple of centimeters. Better remote sensing would be welcome. Given the cost of sonar mapping voyages, Mayer says, I would love to see it threaten what I do. I would love to see it threaten what I do. Yeah, I don't get it. But anyway, every colorful dot here on the map is a possible crypto geyser or volcano in general. Thank you